Hello and welcome to the introduction on how to use EquiPop. Before we start the software of EquiPop, we are going to take a closer look at the file behind the analysis. In this case, I've opened it up in ArcInfo, and it contains actually just 5 variables, even though it looks like it is 6 variables. In this case, it says I've got the place code here, I've got the east-west coordinates, I've got the north-south coordinates, I've got a variable counting all the people residing in all of these locations, and a classification of belonging to a subgroup. So these 5 are part of the original variables included in analysis. The remaining one, in this case something telling us that we've got a shape variable, and the first one, an OID, are simply variables being added by ArcMap itself. The reason I'm showing you this is that it's usually a very good idea to take a closer look at the data that you're trying to analyze. In this case, the prime reason is to see how much differs in space between these two locations, and all locations really. So as you can see from the east and the north coordinates, we've got values ending on 50 in both cases. So a quick thinking means that we've got approximately 100 meters as the smallest unit of distance between any point. And if we move to the right corner and I click the zoom tool and I zoom into some area of this spatial make-up mock world, we can quickly realize that each of these dots are located on 100 meters distance. And you can also see that these units are being meters, since that in the bottom part is just some kind of measurements of north, south and east, west coordinates. Again, I repeat, these are just mock data. The locations probably end up somewhere in Africa. They are not based on a real set of variables, but are mixtures from a variety of sources that I've come across. And the reason, of course, is that we should be able to test them and try them without risking any individual information that might not or mustn't be revealed. So this is what we've got. So everything's just mockery, but it's fun for analysis. So these are the variables and these are the distances being used. Okay, I move on to EquiPop, and this is how it looks upon start. We've got 3 different menu items. We've got zoom in to file, which contains open and save, these and exit, of course. These are hardly any difficult things to realize what they are. We open a file and we save the result, or to save the template. We've got tools, which means that we activate the equipment EquiPop in the first round, and we can also configure certain internet settings and server settings. This is nothing we're going to do this time, but perhaps in another video. And eventually we've got a help, which is an about box telling you something about what EquiPop is and things like that. Well, we start with opening a file. So I click File, Open, and there we open up a new pop-up kind of a menu which contains the Browse button. And if I click that one, I've got the possibility to choose data. The data I'm going to analyze is called population. It's got the file suffix of DAT. So down here in the drop box, I'm choosing, instead of text, I'm choosing tab separated text, so I can see it. I click it and I click öppna, which means open in Swedish. So this is what I've got. These are the variables, and you just saw them in ArcMap. There are the place code, east, north, all people in subgroup. We need to tell the software what function which of these variables actually have. So I must drag the ID variables to the place code, telling it that, well, this variable actually just contains some kind of information of where we are, a name or something like that. The east-west, I drag and drop onto east, north-south to north, count all to all people, count subgroup to subgroup. If I had more, I could drag the none value on top of or something else. I may at this point also enter a value of the minimum distance determining the space between units. In this case we saw in the ArcMap that it was 100, but I can also leave it blank because the program will itself figure it out. So I click OK. And then it's time for me to define the reporting intervals, the count of individuals for which the quotas and statistics are going to be calculated. I usually do like this. I have the 12, 25, 50, 100, 200. So doubling sequences, because it always shows very well on a logarithmic scale, and it also makes sense from a variety of ideas when we are thinking of a neighborhood. For instance, a neighborhood of 12, 25, 50 and so forth really means different things. If we just add them at on a fixed sort of 100, 200, 300, 400, we have very many useless, if you like, reporting intervals which cannot be used to a very large extent. So these are the intervals that I've been choosing. They are really on the top side because the statistical material that is for testing actually only contains approximately 25,000 individuals. So if we're looking for the 12,000 nearest neighbors, we are going to have very little variation going on, and especially we're going to have edge and border effects, but that's something for another issue and a debate in another video. What are we going to report? We can include distance, in this case being reported directly in meters and with 2 decimals, so the approximate centimeter between. If we take it away and just have 0, it means that we've got the meters, not the decimeters or centimeters. I usually only include count all and include ratio. I usually deselect include count group, because you could if you've got the idea of how many the count all actually reached, and you multiply it by the ratio, it is really interesting, very simple to reconstruct the subgroup count. You might wonder what I'm talking about. If I've defined 100, for instance, I'm highlighting it right now, why should I include count all if I know there's 100? Well, if you remember the statistic from the ArcGIS environment, we could see that actually some of the coordinates had more than one person. They might have perhaps even 20 or 30 individuals at that coordinate, because it's a high-rising building or something like that. And that means if we add 10 plus 5 plus 10 and so forth, and we want to have 100, but we actually end up having 105, that's something that we must report. We cannot just out of random deselect 5 of the people being added, because we don't know which one of these 5 are being located closer than the others. So we will have to do with the 105 that we got in the k-nearest neighbor analysis and just report it instead. So if we include count all and include the ratio, we've got a control over if the count is, if we got a very large overshoot or not. This is usually not a big problem. It is only a problem if you're using very big kinds of data, chunks of populations like municipalities or parishes or something like that. And if you try to combine them and have very low k values, then you probably will overshoot very often. But if you are using blocks or 100-meter units or even individuals, then the risk is really very low. So you might also use the decay parameter if you like. So you might have the idea that the 100 nearest neighbors are important, but the ones being located closest are more important than the one being most distant. So if you got a good idea about whether that kind of decay is exponential or power or anything in between, you might define that in the decay parameter box by writing a number and choosing a decay model. If I choose, for instance, exponential, I'm having an idea, since it's meters, like 0.0003 or something like that, I will have a decay of what is important for more distance locations. In this case, I'm not interested, so I'm going to take away that number and choose none. And I'm clicking the Run Analysis button, and the analysis starts. And this means that you can see the progress bar up here is showing and indicating how far the analysis has been going on for these coordinates and for the population within. And as you can see, fairly quickly the name population dot turned blue, which means that it's been transformed into a link which contains a zipped file which contain two sources of information. Partly the one you can see in the alt box showing k values and rectification units and whatnot, and the other one the summarizations, the data if you like itself. So I'm going to click it and we end up here, and I don't know if you saw it, but down here in the corner we see the population zip file, and unfortunately when I click this I cannot show, so I must minimize the window. If I do that, it says open in Swedish, open always files of this kind, or show in folder. I'm not going to do this right now, but as you can see or understand, this is a zipped folder containing all the results and material that we need for, well, further analysis. So thank you for that, and please watch the next video on how to use EquiPop. Right.